Hello everyone and welcome to this video on making a tower defense game in Unity. Today we are going to have a look at unlocking levels. But before we jump into Unity and get started, I just have a few things that I wanted to address. The first one being I'm now on a fixed video schedule. That means every Wednesday and Sunday, that's Wednesday and Sunday, I'll be uploading a new tutorial. I've actually been on this schedule for quite a while, but for some reason I just haven't really told it to you in a video, and yeah, no particular reason why, I'm just a doofus. And the second thing is I got a new camera and I've been experimenting a bit with kind of the layout and setup for these tutorials. So let me know what you think of this new setup, and yeah, please be constructive about it, but I definitely want to hear what you guys have to say so that I can fine tune it, because I'm still figuring out some of this stuff. And that's also the reason why this particular video is uploaded on Thursday and not a Wednesday, is because I messed up something with the new camera. It's pretty embarrassing, but I shouldn't have nice stuff. So yeah, I had to postpone it a single day. Oh, and I forgot to mention that this previous weekend was Ludum Dare, which is an awesome game development competition where you get 48 hours to make a game from scratch using only code and assets that you create yourself. I participated, and you can find my submission in the link in the description. So check that out if you want, and definitely expect a behind the scenes video as soon as I can get that done. So yeah, let's jump into Unity. So let's get started by opening up our level select scene and also our level selector script. So just double click that and it will boot up in Visual Studio. And here you can see we simply have a reference to our fader script, which is responsible for changing scenes smoothly. And we also have our public void select. And that's currently just called by the different buttons. But our script has no reference to the buttons in our scene. It doesn't know what they are. They simply call this function. So let's start by creating a list, or more specifically an array, of all of the buttons that we currently use in order to be able to change to a certain level. So to do that, let's create, of course, a public variable. And we need these to be of type button, but that's not included by default. We need to go up here and say using Unity Engine .ui. And now we have access to the button class. Then we can call the button array here, and we need to mark it as an array by opening and closing these square parentheses. We can call this one our level buttons. Now when we save this and head back into Unity, and when we then select our level selector object with our script, we should see a new array that we can resize. More specifically, we can add 2 new elements. And of course we want to add our 2 buttons here. So let's just find those under the scroll rect, under the content, and we have our first level button and our second level button, and we'll just drag those in. So what this allows us to do is now in our script, at any point, let's just choose the start method here. So right when we boot up this scene, what we want to do is loop through all of our buttons. So we want to go for, and whenever you create a for statement, you could go ahead and type it out yourself. So for int I equals 0, we want to go as long as I is less than level buttons dot length. But this is always a bit redundant. What we'll do instead is just write for and then tab, and that's going to automatically insert all of this stuff for us. So we can name our variable. We could call it J, for example, but we'll just call it I. And we'll also change the length here to level buttons dot length. And this way we quickly have a for loop that will go through, and for each button in our array up here, we'll create a variable I with the index of that button. So we'll just keep going until we reach the end of our array. And what this allows us to do is now say level buttons to the ith element. So which is the first time we go through, it's going to select the first button, which has an index of 0. The second time, it's going to select the second button, which has an index of 1. And of course, it's going to stop there for us, but you can have an unlimited, or at least a pretty long list of buttons on here, and it's not going to complain about it. And then we can go .interactable, and we can then disable the interactability of these buttons. So all this really does through script is go to our button and then disables the interactability here. So it just toggles off this switch right here. And of course we do that for both buttons right now. So if we go and hit play, we should see that we don't see any hover animation and that we cannot actually click these buttons. What a standard button will do, just a default one, is because it uses the color tint as a transition, we'll go ahead and maybe fade out the button a little bit so it's clear that you cannot interact with it. But we don't do that at the moment, so let's instead go in and create a small animation just like we have the normal highlighted and pressed. We also want to go and do something for the disabled, and what we want to do with this animation is simply find our color and then drag down the alpha quite a bit, just to make it very, very clear that this button is not to be interacted with. But remember, whenever we change a parameter on one of the animations, we have to make sure that it goes back if we then re-enable it. We don't want it to just change its alpha, and if it then goes back to normal, it will stay at that alpha. We of course have to input a keyframe here for the color as well, where the alpha is 255. So we'll just go ahead and duplicate this keyframe here and paste that under highlighted as well and under pressed. So it's only when it's disabled that we will get this faded color. And we can do this on one of the objects only, and we don't even have to do any applying of the prefab because they all share the same animation files, and that's what we've just edited. We just edited right now this button here that has the disabled, highlighted, normal, and pressed. Cool. So what we should now see is that when we hit play, they're both faded out, and that's awesome. One thing that we of course do not want to happen is that right now both of these buttons are faded out, and we want to always be able to choose at least one. So of course we have to keep track of what level we're currently reached. And in order to do this, it's not enough to just create a variable, because a variable won't persist between scenes. If we create the same script in the first scene and in the second scene, it's not going to carry over. If we mark it as a public static variable, that is totally going to work and it's going to carry over. But as soon as you close down the game, your progress is going to be lost and the static variable is just going to go back to its default value. So what we do instead is save our progress to some kind of file. Many advanced games use some kind of data format for this, and that could be JSON or XML, which are basically just formats for storing loads of data. Say you want to store player health, player progress, levels, all that stuff. Maybe even where objects are placed in the scene, where your player is in the world when he logs out, stuff like that. You can store a lot of stuff in those formats, and you can definitely check that out. It's called serialization. But what we do, which is a lot easier, and it's something that Unity has provided us for this use case specifically, is use the built-in player prefs. And this just allows us to store either a string, a float, or an integer. And you can store multiple integers, multiple floats, multiple strings. So you can actually use it for a lot of stuff really, really easily. So what we do in order to utilize this function is let's create a new variable and let's call it level reached. This is going to be the level of the highest number that we have reached. So in the beginning, this is going to say 1. Then when we beat that level, we get to go to level 2, so level reached will be 2, and so on. So we don't want to set this equal to either 1 or 2. Instead, we want to set it equal to the level that we have reached. And therefore, we go to player prefs, and you use this whenever you want to get a value or set a value. And then we do dot, and in this case, we want to get a value. So we go get, and then you can see we have both string, int, and float. And in our case, because it's a limited amount of levels, we want to just use the integer, some number, some whole number. So let's use getInt, and then we give it the name of the key. And the key is basically just a string value that you use to associate with that number. It's basically the same thing as a variable name. So if we treat this integer as a variable that has a value and the key to get that value is the name, this uses the exact same thing. So our key here could be the exact same level reached, and I think we should just do that for simplicity. We also get to specify a default number. So in our case, we do comma 1, and that's because we want our default level reached to be 1. We do this so that if we have never played the game before and it tries to go here and find a saved piece of data called level reached and it isn't created yet, it's just going to return the value 1, and so it's only going to allow us to play the first level. This is going to happen every time a new player plays the game. So now we can use this level reached in order to specify what level buttons we want to actually be interactable. And we do that by saying that if the current value of our I here, so if I, which means the index of the button we are currently on, is less than level reached, well then we want to go ahead and make it not interactable. So if we haven't reached that level yet, if this current button has a level index that we haven't reached, we want to go ahead and make it non-interactable. But of course our I here starts at 0 and obviously our level reached starts at 1, so we have to just add 1 onto the I in order to make that totally valid. Whoops, I noticed a bug here that we have to fix before we run this, and that is if I plus 1 is greater than the level that we've reached, then we want to disable it. Awesome. So we can save that, head into Unity, and what we should see now is that when we play the game, it's not going to have any previously stored data, and so it's just going to return 1, and that means that the only button that's going to be clickable is the first one, and the second one should be grayed out. So if we hit play now, we should see exactly that happening, and that's awesome. And again, we cannot click this, but we can proceed to the first level. So that's actually all we need to do for our level selector. But of course we still have to change our level reach so that we can actually progress in the game. It's not going to do that automatically. So what we do here is head into our first level. We find our game master. So let's find the place in our code where our level ends, and that's inside of our wave spawner. So let's double click that and scroll down here to where inside of our spawn wave, we realize that we've just spawned all of the waves that we wanted to have in this level. We currently just throw out a debug.log statement saying that we won the level, and then we disable this script. What we want to do instead is we probably still want to throw out a debug.log, and you might even display some cool information here, like the amount of waves that you just went through and the amount of enemies you killed, cash earned, stuff like that. But what we will also do is of course increase the level reached. So in order to do all of this stuff, I don't want to do it inside the wave spawner. I want a more appropriate place to put this code. And that is of course inside of our game manager. This is responsible for ending a game, and so I think it should also be responsible for winning a level. So let's go in here and create a public void, and let's call this one something like level 1, or you could just put win level, which I think we are going to put. And in here we could throw stuff like a debug.log statement, and I think we're just going to copy paste that in there so we know what is going on. And of course we need now a reference to the game manager inside of our wave spawner in order to call that function. So let's go to the top here and let's create a public game manager, and we're going to call it a game manager as well. And let's go down here and say game manager dot, and then we call win level. Then inside of our win level script, we throw out the debug.log. We could then go in here and say player prefs dot, and now we don't want to use get. Now we want to use set. So we use set int, and again we input a key, which is the name of our value. So our name is level reached, and it's very important that you type this the exact same way that you did inside of the level selector. It's not going to throw an error if you didn't. So just go in here, copy this, paste it in here, and you're good to go. Just make sure that that's correct, because it's not going to complain about it if you make a mistake. And then we throw a value, and the value here could be, in our case, we want to transition to 2 if it's the first level, and to 3 if it's the second. And so this is something that will dynamically change. One thing you could do is keep sort of an array, a list of all of the different levels with an associated index that you put in here. That would be totally fine. Or you could, at the top here inside of the game manager, have some variable that start with a public string, and this is going to be the name of the next level. And we'll just default that to level 2. And we'll also have a public integer, which is going to be the next level index, or we could call it level 2 reach, or let's say unlock. And we can default that to 2 as well. So this is a bit more fragile because you'll have to remember to write everything in there, but you will have to add it to the level array anyways, and it's just a lot easier. So now we simply input level to unlock in here, and then when we want to actually change the scene, we of course need another reference, and that's to our fade script. So we'll go up here and again, and we'll create a public screen or scene fader, and we'll call this one scene fader. And now we can go down here and type scene fader.fade to, and the scene that we want to fade to is the next level. Awesome, so that should actually work just fine. So now we just need to go into our game master, and we need to input this new information. We need to drag the game master or manager inside of the wave spawner's game manager. There we go, so that's linked up. We want to drag the scene fader into our game manager, and we want to confirm that our next level is level 2. That's correct because we're currently on level 1. And the level to unlock is also 2. Cool, that's also correct. So now we can just save this and it should work right away. So let's go to our level select. Let's hit play. And we should now be able to go to the first level here and run through it. But that's going to take some time. So I thought we would just take a shortcut, which means just loading up level 1 and finding our wave spawner and setting the time between waves to 0. Just so it will really quickly run through here. So let's just put in a lot of objects or game objects here to kill off the different waves as they spawn. Awesome, so you can see how quickly that went. And you also noticed a bug, but it transitioned to the second level here, so let's focus on that and we'll fix the bug in a second. So it transitioned to the second level, and now we can go and choose our level select again, and we can just hit don't save on that, we don't need to do that. Hit play. And you can see that they are both unlocked. So that's awesome, and it's going to keep doing that. If we create, say if we just very quickly go in here and create another button. So just duplicate level button 2, and we change the text here to 3. And we go into our level selector and add it to the array. So go 3 there, add it in there and hit play. You should see that that's not unlocked, and indeed it is not. So you can see how easy it is now to add new levels to this system. So now let's just focus on our bug, and we'll call that a day. So let's go into our first level here. And basically what happened is it marked the level here as completed before we had actually destroyed all of the enemies. And it even went on to spawn a wave before a previous wave was completed. And the reason why is because of the way that we're currently checking if a wave is done. And we do that by, if we go into the wave spawner here, each time we spawn an enemy, we increase enemies alive by 1. And then when we kill an enemy, if we find our enemy script, so we'll go and double click on the enemy here, every time we die, we decrease enemies alive. And if enemies alive reaches 0, it's going to go ahead and spawn the next wave. But the problem with this is that we of course instantiate the enemies with a bit of delay in between them. So we don't just go ahead and spawn all of the enemies at the same time. You can see here that we wait the wave rate, so 1 divided by the wave rate, and therefore there's a bit of delay between each enemy spawn. So if an enemy spawns and we destroy it before the next one, the amount of enemies alive is going to be 0 in the middle of the wave, and if we are unlucky, it's going to start the next one or transition to the new level. So in order to fix this, instead of increasing enemies alive when we are spawning enemies, we're just going to set enemies alive equal to wave.count before we actually start spawning. So this way we'll just set the enemies alive to the amount of enemies that are going to be spawned, and yeah, just use that. It's much simpler and it should work much better. So if we now go in here and set our time between waves to something like 1, let's just decrease it a little bit, and we'll very quickly just run through this. So let's create a bunch of turrets to take care of our enemies, and we'll create some of higher level as well. Let's use the laser beamer here. You can see that the previous wave does not start until you've actually completed the or the next wave doesn't start until you've completed the previous one, and once we get through the last wave, it's going to transition. So now that bug should be gone. Awesome. So you will notice a slight disadvantage when it comes to just duplicating levels like this, and that is all of the changes that we've made to our game master in here have not updated in level 2. You still have to set up the scene fader and game manager in level 2. What we can do, since we don't have anything special going on in level 2, is just delete that and then reduplicate the level. But of course, that's not super awesome if you have a lot of stuff going on that is different between the two levels. What I would then recommend is you can of course go ahead and make all of these different objects into prefabs that you just make sure to update whenever you change them. You can get really far using that method. But if you're really serious about this and want to create a lot of different levels, what I would recommend is you utilize the fact that Unity has now created a way of loading different scenes in. You create one scene for all of the stuff that is shared between all of the scenes, like the game master and the scene fader, the node UI, stuff like that, that doesn't necessarily need to be interlinked with the actual layout of the level. And then you have another scene which is different for each level, which is the actual layout of the scene. So that's something that you might take into consideration. If you want me to show kind of how that's done, of course, let me know. I think next up is probably some screen that will display in order to show how you did in a level. I think that's pretty important instead of just going directly to the next one. But that was pretty much all I wanted to show you in this video, and I will see you in the next one. Thanks to all of the awesome Patreon supporters who donated in November, and a special thanks to Sultan Al Sharif, Faisal Marifai, James Calhoun, and Robert Bonham. Become a patron yourself at patreon.com/Brackeys.